Hello everyone, time for more Voron Livestream testing thing. So yeah, welcome back. Today we're going to be doing more speed testing, acceleration testing, try and find like max flow rate and stuff like that, find some print foley things. We looked at this like graph thing that I made last time, and today I kind of want to try and plot that. Not like, obviously, precisely with like 1,000 points or anything, but a few. So I'm going to go through a few different settings and try and fairly quickly find maximum accelerations. Maximum acceleration at various, one of those two. Yeah, maximum acceleration at various different speeds. And then I'm going to try and plot them and we'll see where we get to. And then we can correlate that with some flow rates, try and find out maximum flow rate or something approximately close to it, and see what we find out. So this stream, well, this set of streams, this printer, all the parts were provided, or most of the parts, a good portion of the parts were provided by LDO, OneTwo3D and BigTreeTech. So you can find out more about the parts and stuff that I've used in the bill of materials, which is linked below. Hello to everyone joining in. Good to see you all. Hello, 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 hello. Oh goodness me, I'm yawning at the start of a live stream. That's no good, is it? So I think since last stream, I don't think I had these done then. I have printed off baffles for daylight LEDs. This one's kind of assembled because I was taking photos and stuff. But basically, the camera won't focus because I put it into manual focus. But basically it means that when you mount it on the side, you can see with the new mounting block design, that when you're at an angle, you obviously can't see those LEDs, which means the light from the LEDs also won't get to you. But when you're like in the printer, it doesn't block them at all, other than at extreme angles. So you get much more kind of direct and purposeful lighting. That sounds a weird way of saying it, purposeful lighting. But it just means you don't get a lot of light spill out the front of a printer, or at least as much. And it's a little bit less glary to look at, which is nice because it never shines directly in your eyes. It's only off of things that are already in the printer. So yeah, that's the thing. All the LED stuff, RGBs and stuff, all still in stock. I've ordered more stock, so as they're starting to run out, more will be coming in. So don't worry about that. Keep ordering. And there'll be, I won't say that. That's a secret. So let's do some testing. So I kind of got to remember what we were doing and how we were doing it. Printer is on. So from here, we should have operational printer. And the Raspberry Pi just gets ridiculously hot for some reason, even though it's a 3B and not anything more. But as soon as we start heating, that fan will kick on and that Pi temperature will drop quite quickly. The only reason we're preheating is for making sure that anything we do obtain is going to be comparable during actual printing. Because obviously there's no point tuning if you can't then do the same thing when you're actually printing. So let's make sure all these movie things still work as they did before. The configuration files, by the way, are up on GitHub now. So if you're interested in more details of my calibration and stuff like that, you can find those all available now. I was going to try and do like a donation thing on my website, but it was too complicated to set up, so I didn't do that. I think you can do donations or support, can't you, through GitHub? But I couldn't work out how to do that, so So we didn't do that either. That's QGL, nice and quick. For those that haven't seen this before, we got a speed testing script. You can see a little bit here on the right. So Andrew Ellis's GitHub on the print tuning guide. Hello Alex. We've gone through this guide of determining maximum speeds. There's this printer macro, which looks like this. And it does a bunch of things, which basically allows you to tune your speeds, accelerations by doing a number of different iterations of a movement thing, like a diagonally moving thing, which is all very nice. So what we're going to try and do, we have this. So I'm not sure which numbers we're going to pick. So yesterday we did 300 and we started very, very low, but we got to, I think, 80,000. This is in millimeters per second squared. And we have the maximum speed in millimeters per second. And we will find out some of the other ones. So I think we kind of did a 450. It's already heating. Heating is already begun. I'm not sure if like 100 is going to be worth doing. I mean, the acceleration at 100 is going to be so insanely high. But we can do big jumps, so we can do jumps of like 10 or 15k or something to help us tune in. And then obviously when we get into like 600, that's when our accelerations are going to drop massively. But it should be a pretty interesting experiment to find out where we get to. And once we've filled in a bunch of these numbers, I want to do 5 or 7 or so. It doesn't really matter too much if they're evenly spaced or not, but evenly spaced is probably better. And then we can plot them, we can make a graph, and then we can have some predictions regarding flow rate, and then we'll do flow rate testing. So just as a quick demo, I think we're probably still heating up. Bloody hell, this thing heats up quickly. So it's not fully like heat soaked yet. As you can see, the chamber is only at 30. But we have this pretty ridiculous little script which runs this nice speed test. So, for example, this. I think this should work. We don't want 50 iterations. Oh, balls. Oh. I'm just doing a hard restart because I really don't want to wait for 50 iterations. It's a Rapido hot end, and it's their standard nickel plated nozzle, which I believe is copper nozzle. But I've got some other hot end nozzles as well. I've got a whole bunch of these diamond ones of various sizes. So these I've got in like, the sizes are written on them, but they're still quite hard to see. 0.6, 0.8, 0.25 and 1. And there's a 0.4 which is in there already. So in theory those should be quite good on a materials basis, but I don't know the details on their internal geometry. Yep. And then I got CHT as well somewhere. I got a 0.4 and a 0.6. I don't think they're installed in printers at the moment, so. Okay, we're gonna have to do the homey stuff again. And preheat. The speed of these is way more than the speed of those. I think we could definitely improve our Z speed still. Okay. So, I'm just trying to do a demo, but I typed in the wrong number. This is the kind of thing we're going to be doing today. So this is 300 millimeters a second at 80,000 acceleration. So very high acceleration. But not that high in terms of speed. Yep, 80,000, you can see acceleration here at 80,000. Oh, that's me. But this is fairly low speed. Nice, 540k. I mean, I'm not sure your hot end's going to keep up with that, but yeah, I mean the Voron, the V0 is so light. It's obviously pretty easy to go pretty fast. How many did I do? 10. Okay, so that's a little example of what we're going to be doing. Each test won't be anything like that long. So what we kind of typically do is maybe 2 iterations. What we want to check though is what speeds we're going to start at. So max velocity 300. We're kind of done with 300 and we got 80k, which is what we just tested. So now we need to find out what it's going to be like at a different speed. So we'll try 400. So we'll put 400 in the velocity, which is faster, which means the maximum acceleration will drop. So we should find it's, I don't know, like 50k or something. Probably less than that even. Make sure we're keeping it warm. So we got one value, let's go find another one. Console. So acceleration will maybe drop to 50k and do 2 iterations and see if we make that. So I need to be ready on emergency stop here because if it starts to go wrong, it can go pretty wrong pretty quick. There you go. You might have caught that, it just kind of stops and make a big high-pitched squeal. So we're going to have to drop the acceleration further to try and achieve the acceleration. So I've got the clipper screen down here, which has got a emergency stop button. So that's how I'm doing that. So I think we don't need to go, oh, we do need to do preheat every time. That's the annoying thing. So let's drop quite away. Let's try 30k. This looks reasonably healthy. So now we can just run pretty much the same test again, but we'll increase it by 5k and see what it does. We do have to do a quick little check on the stepper motor, so you can see on the left there where it says MCU stepper X, and there's another one a few lines down. We have to compare the numbers between one and the next. If it skips, it means, well, if there's a big change, more than one step difference, then there's a good chance that something's gone wrong. So 35k was too much. Oh yeah, so I forgot to recharge my microphones between the last stream and this one. I've got an idea. I forgot to charge my microphones, is what I'm saying. The little wireless lavalier thing. So I'm just plugged in directly today via this thing, which is kind of annoying, but it is what it is. I have not done this with the V2.4r2 actually. My V2.4r2 doesn't run super smooth because of the assembly method where the rails are not quite perfect. I'll do some V2.4r2 stuff at some point. I've not touched that in a little while. Well, I use it for printing, but so that's 33k, so we're right up at the boundary because 35 failed. So we've got to be pretty close. So we'll put 34k for that, because we know 35 failed, and I don't think it's much point going more precise than that. So now we'll try 500, and we'll drop it down again. I did say I did see your guess of 30 to 35. That was a pretty impressive guess. But then you have basically the same printer. So Was it a good guess or was it cheating? So now we're going to drop a whole bunch again. Judging on the drop that we've got here, it's probably going to be like 10 to 15k maybe. So we don't want to go too heavy. It's quicker to go up than it is to go down, because when we go down it does an emergency stop and we have to restart every time. So console. So maybe we'll go for just 10k, but it should be super high speed now at 500. Who else wants to make a guess before we run this test? What's the acceleration going to be for 500? There's no actual prizes, by the way. Just so you know, it isn't a competition. It's just for funsies. Interestingly, there's the, I think it's this one, this is where the preacher thing is. Yeah, so if we've got acceleration of 10k at 260, going for 500, it still reaches the maximum pretty fast. We're getting to the peak speed fairly early on in that motion. It was very smooth that time. I could, like, you could see, you didn't get the whole like thud every time it changed direction. It was a very smooth transition between speeds. What I'd really like to see in addition on this macro is if it would time the motion. I mean, I guess it's all just, you could just work it all out, and you don't need to time it. So 13 was good. Let's try 15. If this doesn't work, we just put 14 as the answer. Actually no, because we don't know that 14 succeeded. We should test 14 if this fails. And 17. Maybe it's not going to drop off as much as it did for the first one. We dropped more than half of our acceleration, and now we're over half. $17 looked fine. Can we go on 19? Remember we hit 20, we ate 28 for 450, didn't we? Yesterday, I think. Oh, yesterday, Wednesday. Me too. We've got to be, there we go, that's the limit. So what did we succeed on? Succeeded on 19. So 20 next, temperature, ABS. I'm doing the preheat on the screen, by the way, because it means I don't have to change the web interface back over screens and reload everything. You can just about see the top of the screen where I'm doing that. So acceleration 20k, let's try that one. So it should be 20 or 21 will be our final result here. I just realised wasn't our failure, was our 80 our successful highest, or was it just the one that I felt like, oh, we'll go with that? That was 21k. No, that was 20k, let's try 21. Okay, 21 works, 22 didn't. So 21k for 500. I think 85k worked. Yeah, Alex is saying 85k worked. I think I keep saying yesterday, don't I? When I say yesterday, I mean last time. No, test speed is not a default cable command. It's part of this. Andreas's print tuning guide. I'll paste the link in here. My computer is struggling pretty hard today. My 8 gigs of RAM are not enough. Oh man. I don't know how this computer still manages to stream. It's actually a miracle. So yeah, that's the macro. If you read through that, you'll see where the macro is. It's quite advanced. I mean, not like the writing of it was, obviously, like using it's a piece of piss. It's the way around it should be. Temperature, ABS. I think the ABS configuration on here is different because it's only going to 220. But anyway, it doesn't matter. Machine, printer. So that's 500. We're going to try 600 as well. It's barely worth it because it's so ridiculously fast and the acceleration is going to be so incredibly low. Yeah, I could set it in the macro. It's just easy to track if I'm doing one thing at a time. Otherwise I forget which one I'm changing. Yes, so with this we could have one acceleration for doing our outer perimeters and a different acceleration for doing internal. So we could do our internal ones at like 300 millimeters a second and like 70k acceleration for infill, and then switch to like 5k acceleration for doing perimeters. So I think we'll go down to 10k and see what happens from there. The downside is it means I don't have separate bloody print profiles for each of my printers, but there you go. It's so much easier when you just have one profile that does everything. Oh, that's a fast boy. That's really scooching, that is. Woo! Whip, whoop, zip, 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 zip. Let's try 13. And we shouldn't drop that much. Maybe I'll just go to 15. Ooh! That did a big thud. Let's move that away from there. I didn't quite press it fast enough that time. Please come back to live. Yes, temperature, ABS. Filament and printer dependencies. Oh, this sounds even more complicated. I turned off dependencies because the filament, oh, it's just annoying. And let's try 13k. The thing that was annoying about dependencies is like for filaments or something. Like Prusa Slicer has loads of filaments set up for Prusa Mark III, and then you put in another printer because you're like, well, all the appropriate printer filament profiles are there, but with the custom printer, because it's not, the dependency requires it to be the Prusa Mark III, none of them work. You just don't see them. Ooh. So that was what, 13k? That's another fail. Well, that's pretty good. So that was 11K. I suppose we can try 12 as well. $12K. You can't see it down there. So I guess we should do 200. That'll get us 5 points. That should be good. 200 should be ridiculous acceleration. To the point it's going to like tear the printer in half. Maybe we'll just stick with 4. Because this acceleration is going to go up to like 150k or something maybe. And it already sounds dodgy at 80k. We could put in, we could do a 350. Full Sense sponsored kit. Just because it's sponsored, I still want to be able to use it at the end of the live streams. It's not just going to go in the bin when I finish live streaming. Oh dear. So we can go back to some crazy accelerations now. So it's going to be between 34 and 80, we know that much. We don't know exactly where. On the higher side, 30, 40, 50, 55k-ish. 50k to start with. I think it'll get to like 65. Oh no. Less than halfway between that, I don't know. Oh, that was definitely a skip. And again. So a skip, but not a problem. So in fact, well, I might just stick 50k in as a result, because that's like perfect. You go any more and it'll full skip. You go any less and you won't, and we're not at failure point yet. So we've hit the jackpot. 50k, 350. And I think we did 450 yesterday, we can put that in. I think that was like 80. Let's just do, we can do it in here, can't we? I think 28k. Yeah. But that was definitely skipping a lot. Right, that blew up in there, so we're bang on 28k. Okie dokie. So we'll remove these two out. I don't think those are going to be useful. So if we insert a chart of XY scatter with points and lines, bada bing, bada boom. So that's our chart for this printer. The next thing to do is to work out our flow rates and where we hit on there. Now these will be different for different filaments, but I'm predominantly going to be printing on with ABS on this printer. So I guess we're going to stick with ABS testing for now. That 28k looks a bit high, doesn't it? Looks like it should be like in here, like 27 or 26, but this is the graph we have. Remember, it's not super precise, but it's a pretty good indicator. And we've got hopefully the best kind of accuracy in the middle where we've got slightly closer points. Why ABS, not ABS plus print as main? I don't understand the question. Welcome to the show. Is that like a typed simulated noise of a 3D printer? Yes, flow rate test. So let's have a look at this other one that Alex shared somewhere in here. A flow rate test. Okay, it's just testing that. Using issue. So without extruded clicks, it's not a great determination of limitation. Well, we'll give this method a little go. It's basically just extrude until weird things happen. It's very, very approximate, but it should kind of work. We could probably just do it with this. This will only do 50mm at a time, which is not great. I really want to do 100. So we can try this though. So M83 is what? Extruder mode to relative. You don't need one this maybe yes, this can go cold. You can change match extrude length in one of the configs. Oh, where is that? Aha, it's an extruder. So this is the setting, max extrude only distance. So if we go, we might put it back to 50 afterwards. Oh, I keep clicking around the wrong thing. It's machine, sorry, printer. Extruder. Let's set this to 100 because that's what I'm going to use. And then we can just use the interface to extrude a whole bunch of filament. Oh, we're going to have to home again though. We're super high now. Oh, 150, 150, 100. So I'm going to do this. We can just do. So you can see here, there's a. I don't know why it says estimated extrusion 219mm when the length is at 50. I think I can change these buttons. Control. Adjacent, extruder. We take off. One's pretty useless, I think. $100 at 1. Why does it say 438mm at 2.4mm cubed per second? That makes no sense. Well, let's try this. See where we go to. This is basically just a very long prime. It's going to take 100 seconds to do this one test. Are any parts PCCF? Well, stealth burners are PCCF. And the Z motor mounts are. That's about it. I did print the A/B motor mounts in it, but they came out rubbish and I needed to carry on with the build, so nothing else. Oh, look at this, super slow extrusion. It looks very, very pink because of the pink nozzles, pink lights. I mean. I think we can go quite a lot faster than this. This is taking a little hot second, isn't it? It's just being an oozy boy. Oozy boozy. Oh, where's it going? Come back! Right. I think we're going to start at 5 maybe? This is wrong. Let's see what it actually should be. Do the Daybreak Neo lights do white as well as RGB? They're not RGBW, they are only RGB. But if you combine red, green and blue in about the right amounts, it still makes a pretty decent white. I kind of want it open so I can hear for skipping and stuff. That seems fine. Yeah, so technically all to one and it would be white, but sometimes if the green comes out a bit brighter than the others, it can just be a bit off-white, so you might want to put them maybe at 0.9 and then 1 and 0.95 or something, if you want to make it a nicer white, if you see what I mean. But I mean, those colours will add together to make white, so. What's our temperature at? 250. Oh, that's skipping. Where are you going? Come back. The only reason I was going to keep it closed is because I know it's quite loud for people with the microphone or with headphones and stuff, so don't worry, I know the reason for using a chamber. I think 11 millimeters a second seems to be about the limit. It doesn't seem to want to go much more than that. I have been quite gentle with the extruder current. Seems to be quite happy with at 11 though as a maximum flow rate. 10.5 is probably better. So let's just check with my own calculators, because flow rate, speed of 11, 26.5, yeah, okay, I'm happy with that, I agree. It's at 250, I'm not going to go hotter than that, that's how I normally print it. It is the stepper motor skipping rather than the teeth. I think the I've not got the motor on maximum current, but this is fine. I've lost my train of thought. Let's have a drink. The temperature drops quite rapidly, so our PID response I don't think is particularly great. We're dropping a couple of degrees during that extrusion. So about this. So what printing speed is that? So I've got this little tool. I make myself quite a few different calculators. So the other one I just used a second ago was this one. So I have this whole calculator for speed to flow rate conversion, and then I have this one for speed to flow rate conversion. So layer height 0.2, line width 0.4, print speed of that, cross-sectional area is that, flow rate is that. So if our maximum flow rate, as we've got here, is 26.5, we get these kind of speed ranges. So layer heights down here and line widths here. So if we put 0.2, 0.4, 0.6, we could put 0.8 here as well. Why does it change the height? 0.8. Goodness, this free tool is not as good as Accel. So 0.2, 0.4 gives us 371. .65 or 0.6, and this adds in some new layer heights. 0.4, 0.5, 0.6. Oh. So if we assume layer heights of half the nozzle width, excuse me, and then these are our key values. So I mean, we could have done 100, 200 range for these other nozzles. I think that sneezing might just be because I've had this open just then. Oh, those damn fumes get me pretty quick. Whew. One. Let's add in a 1mm nozzle here. What spreadsheet is that? It's my secret, top secret spreadsheet. Top secret Vector3D specialist spreadsheets. I make lots of tools like this because I often need to check things, and I don't trust online tools to have done the calculations properly, so I do them myself. And they're often quicker to access if you like forget where other stuff is online. It's nice to have your own tools. And you can obviously put in extra little calculations and stuff with like reverse calculations and like tables and graphs and stuff like this as like quick references. Cross-sectional areas for different filament heights. Low height 0.3, bosh, different speeds, easy peasy. But yeah, for this, so if we look back at this spreadsheet, we now want to do interpolation. I don't know how to do that with this. This would have been much easier with Accel. I just want a fucking trend line, please. Can you just draw points? No. I don't know how to use this software. Surely it can do trend lines. That seems like pretty basic functionality. Ooh, this looks nice. Line. Show trend line. We need a second order trend line, not a linear trend line. Oh, please say there's a... What? Can you only do linear trends? Are you shitting me? Aha, smooth. Cubic. Oh, that's for these, that's not for the trend line. Aha! V2.4r2's work particularly well. That's the best one, maybe? Oh, look at all those lovely numbers. Can I just... I can't use this. How can you not copy the text out of it? So, two, 8, 6, 4, 9, 7, 4, 1, 3, 4, 5, 3 times the speed to the power of minus 2.650865. That's our estimated accelerations. They're a little bit off, but not too bad. If we're going to subtract a bunch from them anyway. So now I'm going to stick in the ones that we found over here. 371. Let's just do that. Oh. I'm going to do that. I'm going to do this. Right. Oh, when you know where buttons are in one software, but this is not the same button in another one. Okay, so put this in here. That's actually the only one of those we can estimate because it's all the others are out of range. I expected everything to be in this range, and it's very much not. We can stick that there, so we can, and then we can put in a safety factor. Times by maybe like 0.8, so 20% under. Maybe that's a bit too much, 10% under. How do I change these number of decimal places? It's ridiculous. 0. So. Let's go 15% then. They are only estimations anyway. But we're going to be a long way off. It's only one of our... We're going to have to go... So our maximum speed we can print really is 371. So all of this lot here, unless we choose to do 0.2, well, it's normally 0.25 nozzle, isn't it? Oh. There's also 0.15 nozzles. They want to go stupidly fast. That's right down here on super high. See, by the time we get to 12, I mean, we can just extrapolate. Let's just do, it's not good practice to over extrapolate, but I'm going to because I just want to see. 93, 59, because we don't know that the equation actually works at that range. I see, look at this. This is why I didn't go further. Look at this. That's the acceleration value. 5.6 million, 5.7 million millimeters per second. It's just, that's just not how that works. Wow, the formatting here is just ridiculously bad. 0 here, because we don't want loads of decimal places. And then we can put that, what was it, 1,000 and something? 1,160 down here. Estimate for that one. And that goes to 2,000. Super, super low. So what do we learn? That printers go fast. There you go. That's my conclusion for today. It's quite an interesting graph. But we're not going to be, yeah, exactly, this is the thing about these estimates, isn't it? How fast do we actually want to go? So I reckon for 0.4, 0.2, 370 is probably not a bad shout. It brings the max acceleration down to a level that's not too much like hammer. Less likely to destroy the entire machine, I think. Likewise for, well, for 0.6, 165, that's, I mean, that could go absolutely bananas. So we might probably keep that, keep the acceleration as it is. I think this is going to be our magical values. They're not really a fixed limit. It's going to be this one here that's going to be do the infill at 0.4 width and 30 kilo acceleration. And call it a day. Why do 30k when you can do 37k? Good evening, Ella. No, not that spreadsheet. What are we looking at? So if I went up to 0.6 line width for the infill, 238. I can maybe get 150k acceleration. I think there's 370, maybe 350. Maybe this one also quite nice value, 40k at 350. So is this on? I do need to work out why my Raspberry Pi is overheating. I think it's just the number of devices plugged in or something. I think that's why my printer crashes if I leave it idle for too long and it just dies. I think the Pi is just overheating, which is weird. Hello. Where's the goddamn thing that I'm looking for? Super slicer. It's got all these things. No, go away. Super slicer. No, go away. What are we up to? 1 hour 17 minutes. So, right. Printer settings, machine limits, max acceleration X. Depends what our maximum speed is, isn't it? Our maximum speed 370. Where are we? Where are we? Where are we? Where are we? I closed my spreadsheet that I used. That was silly. What a nitwit. So, maximum speed 370. Maximum, oh no, we'll do 350 and 40k. So this would be for travel. Maybe we'll do on these ones on 30k then. No, let's go 35k. So we know we can go more. Let's just do 40k. Max acceleration for travel moves. Also 40k. Maybe we'll limit this when extruding. We're going to do these via firmware. That was close. Almost press the end stream button because the bloody corner of this window is impossible to click. What's the temperature of the Pi when it shuts down? It just shoots up and up and up. Oh, when it shuts down? Oh, you mean like when it shuts itself off? Warm, I can't remember. I just know that when I like start it up idle, the Pi just gets really hot. We need settings here. Printer CFG. Max velocity 370. And we'll put maximum acceleration to 45k, was it? Got the mirror of a fish today. Oh, 350 is 45k. The setting on your Pi is set to 150 degrees Celsius. I'm not sure the Pi wants to be 150 degrees Celsius. That is very hot, Ricky. I already have a heatsink on the Pi. And it's only a 3B, it's not a Raspberry Pi 4, so I don't understand why it's getting so hot. That's why this is why it's confusing. So, I'm not very good at slicer settings, but I'll do my best. I don't know why this says perf, it's just not. Print settings. Speed, acceleration. So default is my maximum for input shaping, which was I think like 4,500, or was it 5,500? Let me just check. Oh no, X is the easy one. We want Y here. Y, MZV 5000. Perimeter acceleration. Oh no, hang on, default acceleration. Reset to after the role specific acceleration values are used. Okay, hang on. Maybe like 15k then. Perimeter acceleration, that can be 5k. External perimeter, we'll maybe take it down to 4.5k. Infill acceleration. Solid. We probably don't want to go too crazy. In fact, maybe we do want to go crazy. On solid, it's a bit of a weird one. Maybe. Sparse. This is where we can do our maximum. What was it? 40. God, memory of the blooming fish. Top solid. Something like that. Travel acceleration again can be really high. First layer. Okay. Speeds. External. We can go pretty quick here maybe. Internal. Full speed 350. That's going to be a difficult one actually. Top solid. Bridge speed still quick, I'd have thought. Gap fill. I don't know why this is locked. Why is this locked? Oh, it's blooming reset them all. What the effing hell is going on? What am I doing, chat? And why the hell is it just completely reset after all of the things that I just set up? What the hell? Did I kick that? I thought I clicked save. Oh, this profile's not worth anything now. Delete it. And that's when it goes, why does it fucking go to locked? That's just ridiculous. Oh. Okay. I understand. Internal perimeter. What do we have? 250? No. Infill speed 250, 300, 150. Well, I'd rather set. Percentages are way better to use. Just saying. I'm just going to put 150 like everywhere. Internal perimeters can go faster. Go 150 maybe, something like that. Travel speed, we can go to 350 now. First layer speed. We don't want to overdo that. Max volumetric, 25 is about right. Max pin speed, 350. Oh, I have to do these again as well. Arse bananas, print perimeter acceleration. I know, this is what we want around 5,000, 4,500. Infinite acceleration, 30k. This one, 30k. Save. Yes. Bridge acceleration, 10k. Default acceleration we'll put on 10k. Treble acceleration can go high, that can go to 40k. First layer acceleration, sure, that's fine. Use ZV for the y-axis. What did we get for ZV? $7,200 instead of 5,000. Okay. So that makes this 7,000 makes this 6,500. So let's go update the printer as well. Hertz. This is probably when the Pi is going crazy temperature. Where are you, Mr. Pi? 52. You see, you can see when it went off and the Pi is just climbing this green line. With the fan on it was 32, with the fan off it's already crept up to 52. It's just a creeper. Creeping, creeping, creeping. Lots and lots of creeping. I suppose we should actually do a print now. We haven't got that much ABS left on that spool. The problem with having extra width on your infill is that good infill obviously is there to support the internal structure of the part. It's like having a sparse support structure, like you need it there to support things. Oh, hello, hello, hello. So, I guess we'll go for ABS. Are we satisfied with these settings? Are these accepted? You probably can't see them that well because I can't zoom in on these, so they're all teeny tiny. What should we print with the drunken sailor? Turn off machine limits and when it's printing setup clip rest. I don't know how to do that. Elements, settings, parameters, 3. Machine limits and slicer. It is. It's just on, use also for time estimate. So the machine limits will not be emitted to G-code. They will be used to estimate print time. That also is a very misleading use of the word also, because it's actually only. Should we scale it up a bit? Let's see what it looks like. I mean, there are some crazy speeds in there. There's not much crazy speeds. It's going at like 70 millimeters a second for some reason. Why are you going so? There's like one fast layer and everything else is like 70. Oh, there's a minimum layer time. Filament settings, cooling. Oh, why is it 15? Oh, because it's using the wrong bloody settings. I'm not sure what that random blue line was. 170 millimeters a second with 300 on the infill. That's more like it. Printer go brr. It could be a very hot mess, this print. 27 minutes. Between 7 and 13 seconds. There's still something inside me that's like, this isn't going to work, but I'm going to send it. I think we're quite ready. And in the meantime, I'll have a look at this clipper estimator doobly-doo. You lot probably want to look at this. You can see the window of what I'm looking at in the background in the reflection. So we've got no prime line. That's one thing I'd quite like to have. The first layer is not as close as I thought it was. That might just... no, I think it's probably okay. Holy bananas, Batman. It looks terrible because that first inner ring didn't stick properly. So all the ones above it are not sticking either. It's so bloody fast. That is the fastest gyroid infill I've ever seen in my life. Oh, that is a way to ruin your printer very quickly. That's just an insane vibration generator. Temperature on the Pi now will have dropped probably back to like 32. Pi is 34. Fan speed! Filter fan, hot end fan is at 100%. Fan is at 20% for some reason. I don't think we'll want it 100 because I still want to have decent prints. I don't want fast prints that are absolute garbage. That gyroid infill. I can't believe it's doing that. It does look pretty damn nice though, I'll tell you that much. This fucking infill is not a good idea. You reckon cubic's a bit nicer? That's diamond, like 3D infill, right? Yeah. Oh, the first layer is peeling. Hopefully it doesn't come off the bed, but it may well. It might be that increase in fan speed. Jesus Christ, that prime line macro is like 200 lines long. Camera's working nicely. I mean, you can't see the print, obviously, because it's tiny, but... So we have to go machine. Did I make a macros? I didn't separate my macros from my main config, so it's going to go in the main config for now. And we just call what? Prime line. Yeah. Print end, print start, home or absolute positioning. I think this would be going a lot faster if it wasn't for that bloody gyroid. Oh, I didn't realise you were looking at the second screen. Yeah. Umbilical's holding up though, the cam board seems to be holding up. How's the temperatures? EBB is at 57 degrees, chamber's at 47 degrees. The Octopus and the Raspberry Pi, which are right next to the fans, are at a cool 33. Something's making a noise. Where's your chamber thermistor? You can see it on that image on screen at the moment. You see the drag chain up at the back, that little white bit at the top of the screen that goes off at a diagonal line. There's like a little bit of heat shrink and then a white line. That is the chamber thermistor. It's not a very sophisticated chamber thermistor, but it is in fact a chamber thermistor. It's just a little bead thermistor. Oh, I've lost the window where I was looking at this. Clipper in estimator. Print. It's just a print time estimator. A tool for determining the time a print will take using the Clipper firmware. Currently it provides the following modes. Estimate mode outputs detailed statistics about a print job. Post-process mode can be used as a slicer post-processing script, updating the G-code output file with corrected time estimates. Dump-moves mode dumps planning data for every move in a file. I've not actually used the filament sensor yet. We don't actually know. Well, I'm pretty sure it's not doing anything. It's like set up in the firmware, but it's not enabled. So if we ran out of filament, it wouldn't stop. So it looks like we do need to fix our first layers a little bit. But other than that, this is looking pretty fantastic. This Clipper print time estimator seems like it would be best utilised as an add-in on the Raspberry Pi. Maybe it's too much processing? It can't be that much, surely. It seems like you should be able to upload it and have it as a mod and then just like click a button and it readjusts it, or just automatically readjusts the time estimation on the Pi once you've uploaded STL to it. I don't think it's going to come off, because I don't think that first layer has actually changed very much since the start. So I think, if I recall, when it did that first layer, and it was still kind of priming as it went. So I think that first line around the base there was not attached, but all that infill I think was fine. So I understand that you use it as the post-processor in the super slicer, but it seems like it would be easier to use if it was just on the Pi. Just because of the configuration and needing the Clipper files and all this kind of stuff. It's my lazy Susan that's being vibrated to death that's causing the noise. Those like 30, 40k accelerations are absolutely mental bananas. 40k, 7k, 30k, 10k, 40k, 7k. It doesn't seem to be changing the max acceleration to deceleration though. That's staying at 22k, which doesn't seem ideal. It feels like that should always also change to half the acceleration value. Because I don't think we want 22.5k when we're trying to do our nice smooth perimeters. There is a Raspberry Pi version of Clipper Estimator. Oh, that first layer is curling more. I feel like we're going to end up like 90% done and then it's going to screw itself. I'm going to just be back in a minute. You can all listen to the lovely sounds of 3D printing while I'm gone. Hello, I'm back. And I forgot to give remote access. No, turns out I didn't actually forget. That was somewhat deliberate. Failure is not an option. The lighting is a bit weird. I don't know why one side is red and the other side is white. This I would like to change. Where is that? That's going to be in here, in machine, in our stealth burner LEDs. Printing, red, 1000. Nozzle, on, 0.8, green 0.8, blue 0.8, white 1. So why hot red 1? LEDs. It might be that we're adding a couple of parameters to each other. Nozzle LEDs are on, logo to printing and nozzle to on. Logo to printing, which is red, and nozzle to on, which is everything 0.8. But the left one, I'm certain, is red. That left one is definitely red. Oh, that's 3, 1, 2. For me, the logo is the third one on the chain, so it's index number 3. Oh, you can't see what I'm looking at. Here, I just changed this. This was 1 and this was 2 and 3. Which sort of explains it, but it also sort of doesn't. So 1, yeah, it might help. I wanted to build a Voron for a while, but the cost is a tough one to swallow. It is, yeah. What you can do is start a YouTube channel, then after like 8 years, you can get some sponsors to provide you some kits so you can spend 6 weeks building it. It's a big commitment of time. That's like 7 years of building a YouTube channel over the 6 weeks building it. We're nearly there. I'm interested to see how this top layer is going to look. I suspect it's going to look a bit over extrudy. A little bit mushy. Whoa! Turbo! Oh dear. Please do a slow one. I want a nice slow for the top. That's not slow. Oh, this one's nice and slow. And done. Raspberry Pi stayed at 33, chamber hit 51, EBB hit 65, yeah, 65-ish. Yeah, so the first layer was an absolute disaster. Let's make this down here. Oh, dearie me, didn't want to do that. Yes, I know it's currently very blurry. Give me a moment. Boopity boopity boop. So, yeah, as you can see, the first layer was not good. I'm not sure how much of this is down to Pinder. A prime line is going to help, but even the normal parts there are a little bit not great. I definitely like those closer together, or closer to the bed, I guess, really. Other than that, the top layer looks pretty lush. Not perfect. I mean, when you get the real reflection, you can see a lot of detail that I can't really see with my eyes. Actually, it is a bit rough. Or a bit rough. Rough. I mean, I'm pretty happy with it. It's not iron perfect, but it's pretty bloomin' smooth. But these, I think if I go to the menu, tell me, so the estimate was 32 minutes and it took 31. The ringing on Y. None. Yeah, I mean, the ADXL or EBB mount that I'm using, I literally designed in a rush using half-finished Stealth Burner STLs, reverse engineering all the designs just to get some like resemblance of mounting holes and space claim and everything for all that stuff in a couple of days. We've got a bit of a seam there on the inside, you can see, but it's still pretty tiny. That's pretty bloody good print if I do say so myself. All of those tune-in steps, turns out, they help. Who'd have thought, eh? Can I balance it on this? Yes. I don't know what to do now. Oh, why is it not focused on the right bit? It doesn't see that. My camera really doesn't like the colour red. I don't understand why. You just can't focus on it properly. I didn't calibrate pressure advance really. I just put in an estimate of like 0.04 or something. What I would like to do is a first layer test, because my first layers are pretty balls. Well, it's about 30 mil. We need to do a cauliflower for dimensional accuracy, but it takes about an hour. I probably won't actually at this speed. I don't know if we've got an old cauliflower version. Hum, 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 hummity hum. Where is my cauliflower? Cauliflower! Da 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 da! If you haven't got this already, you should get this. Another 38 minutes. Oh, this is like a million perimeters though. Normally, my normal recommendation is print it with the exact settings you're going to use to actually print something. But for purposes of making it quicker, I'm going to cut corners. And it's more of a demonstration of how to print it, because I don't want to use 40 minutes, because I literally am sitting here watching it print. $24 not height. No time. 30 odd seconds. Why is it going? Is it going slow? I mean, I guess we could do the default speed. Internal parameters we can put up to 250 maybe. 15K on internal. Surely I want that external around the limits of what Input Shaper can do. Otherwise, that's when I'm going to start to get artifacts, or well, ghosting stuff. $22 minutes. Let's give that a go. Have I got enough filament? I think so, just about. I do want to get that Z height a little bit lower though. Where's the... Maybe like that. Oh, it's probably going to reset it when I go for print. Probe triggered prior to movement. Well, that's not good. I've broken the probe. No! My pinder. Yeah, we're going to have to do a restart. The pinder's been shaken to pieces. Oh, let's get this back, shall we? I don't want another clicky. That clicky bloody thing caused me so many problems. Are we there? I do need to grab a nozzle brush cleaning, what's it? I've got a brush installed at the back. I've not set up to actually use it. Probe triggered prior to movement. I think my probe be lefucked. I'll do a proper power off. Maybe the connector has just come loose. Where is it? Ow, that's hot. It's hot or sharp, I'm not really sure, but it hurt. It doesn't look... It's pretty difficult to tell, to be quite honest. Either flew too close to the sun or got too hot. Or just needed to be turned off. What the hell? Or maybe me pushing on the connector? One of those two. I mean, if it happens every time, it means potentially there's something wrong with the configuration where there's... Is it? Maybe it's doing something with the probe that makes it think it's triggered or something? I don't know. What are we doing? I want to do another home. Still got this piece of blooming filament stuck to the soldering nozzle. The best place to have it would be between that homing corner and that bit there, so that every time it does it, it just wipes across it regardless of what's going on. Yeah, so when I did that. Oh, too late. We're going to be doing a prime line during the print now. Oh! We should have different lights. Let's observe lighting scenarios. Well, that is super duper close. What the hell is that prime line? That is a prime line other... Why has it not started the print? Oh man, you can't wait after a prime... Is that supposed to be a little handle to grip it? It'd be great if it worked. So I mean, the nozzle was super close to that at the front there, but it's now far away again. I think our leveling is not great. We don't have a mesh at the moment. I should have a mesh. Why do I not have a mesh? My LED colours are now reversed. It's now red at the nozzle and white on the logo. It should be white at the nozzle and red at the logo. Ah. Put M104S0 then M140S0 in the start print G-code in Super Slicer. Stops it doing a temp way after the print start. I've never had it before. There must be something telling it to do that. Well, at least if the perimeters are not quite in the right place, the that first layer fill is much closer, so hopefully it'll stay stuck to the bed. It's because you start the print with a macro, so Super Slicer sees no M104 or M140 and takes it upon itself to put them in anyway. Well, this is quite quick. The weird thing is I've not had it on my other Voron. Oh my goodness, the living vibrations. Jesus Christ. The poor neighbours. Oh, my poor computer monitors. It's going to shake my bloody computer to death. Yeah, it's a bit sparse, isn't it? It's just the default one. I'm printing the cauliflower. My cauliflower. The Vector3D cauliflower. Oh. Ta-da! With the calibration and the testing and the SKU configuration and the videos. It's a good print. Oh my god, that's the infill. That is the messiest infill I've ever seen in my life. I think it skipped. It skipped. It skipped, it skipped, it skipped. Why did it skip? I did increase the speeds a little, didn't I? Ooh. It's very stuck. It's now a calibration web instead of a calibration flap. I'm allowed to be biased. It's mine. So yeah, settings a little bit too much there. What did I change? This. It's because we've got freaking 30k accelerations for our infill. Could be that, it could be that we were just trying to go a little bit too quick. We'll take the speed down. The motors are probably stonking hot. Where are we going now? Extrude below min temp. Oh, because I've not got the bloody preheat in my bloody things. Bloody, what's it? Start macro. That's why it's been weird. Right, where's this? Print tuning guide. Cooling low times, retraction, print tuning, flow rate, motor currents, max speeds, gantry squaring, useful macros. Why is there not? think I might have accidentally closed the YouTube chat. No. We don't want to actually do status printing until after status is actually done. So that takes the parameters and turns them into numbers, I think. Then we do a G28. What's the difference between G28 and G32? G28 is contained within G32, so we won't do the G28. Bed temp, chamber, I mean, I have other things I'm going to need to put in there, but for now, maybe that's okay. Yeah, I don't know if I like this, to be honest. It just seems to needlessly combine homing and QGL into one command. I don't feel like I want that. Hi, mate. I don't. G90. Absolute positioning. Absolutely fantastic. Oh, sod this. I can't be bothered. It's getting end of the week brain now. I mean, the end of this is moving to 150, 150, 30. So why does it then need to change and move again? Like, it's just... But all of this needs to happen before we do that. That'll be okay. Oh, and it's all gone cold. Maybe we just call it a day. Maybe we'll do cauliflower next time. There's still other things I want to do. I mean, sort these macros. We'll do cauliflower. Filament sensor. Macros. And maybe bed mesh. I think I'm just end of week tired now. There's only so much my brain can take. And I think I've hit the limit. Make sure it'll cool down. The good news is, ooh, I spent lots of time getting pre-orders for this lot sorted today. It's not quite there yet. Turns out, configure a website for pre-orders and everything else that's needed, all the pictures and pricing details, making sure everything is like in stock, available to buy and all this kind of stuff. There's just lots of things to do to make sure everything's going to be okay when we get to the critical point. But it will be on pre-order super duper soon. I'm hoping early to middle next week. There's a bank holiday on Monday here, which is a holiday for everyone. So I won't be doing anything Monday. I might do a bit of work on Saturday or something, but basically sometime maybe Tuesday, Wednesday next week, pre-orders hopefully for this will be all ready to go. In the meantime, go fetch yourself some Daylight or Daylight Neo RGBs. Daylight is not RGB. Daylight is white. Daylight Neo is RGB. The pricing is 90% there. I just want a couple more details before I lock it in, but we're getting pretty close. What else should I mention before we go? I don't think there's anything else particularly. Just thank you all for joining in. Hope it was an entertaining stream. I think it's quite good fun seeing the printer go absolutely bonkers. And it didn't break itself in the process. We had some weird pindery things getting disabled or something. Other than that, pretty successful, I think. So I shall see you all in the next stream, which will be, again, bank holiday, maybe Tuesday, maybe Sunday. We'll see. Sometime over the next few days, hopefully we'll do this. And then we'll probably be done with the Voron for now. I'll get it starting to print some normal things. And I shall, yeah, see you in the next stream. And there'll be a video Wednesday. I just keep adding more things. Just babble, babble, babble. There'll be a video Wednesday. Don't forget to go watch the Voron V2.4r2 review, which went up this week if you haven't already. Other than that, I'm definitely going to go goodbye. Go goodbye? Say goodbye? Goodbye, everyone. Thank you very much for watching. I'll see you in the next one.